So we have our coordinate system. We're ready to start drawing free body diagrams. And so the free body diagrams that we're going to have need to have some important pieces incorporated into them. And so we remember that when we're drawing free body diagrams, what we're doing is we're taking the object of interest, we're moving it off by itself, and then we're labeling all of the forces acting on that object with arrows. So these vectors are really representing what the forces are acting on the object. And so for our case right here, this is going to be our step 3. And so I'm going to take our block, we're going to move it over by itself, and let's go ahead and label the forces that are going to be acting on this. So we know that there's going to be gravity acting here. I'm going to say that this force of gravity is going to be equal to the mass times the acceleration due to gravity. This is going to be pointing straight down. This is always pointing straight down. Then we have the normal force. So our normal force is, by definition, the normal force always points perpendicular to the interface between two objects. And so the normal force acting on the block is going to be the contact force between the block and the inclined plane. This is going to be pointing up at this, this angle. For you guys, it's going like that. And the last force that we have here is going to be the force of friction. Now, the force of friction is going to oppose the direction of motion, or the direction that something is going to tend to want to move. And so in this case, this block is going to tend to go down the inclined plane. And so what that means is that our force of friction here is going to be pointing up the plane, right? So it's going to be directly opposing the direction that this is going to tend to move. I'm going to label our force of friction as just this lowercase f for the time being.